Hello and welcome to section 1.4. We're going to be talking about angles, different types of angles, and angle measure. Let's first define degree. Degree is a unit that results from dividing the circumference or the distance around a circle into 360 parts. So 1 degree is 1/360th of a turn around a circle. A ray is a part of a line. It has one endpoint and extends infinitely in one direction. So I like to say a ray is a combination between a segment and a line. So you can call this figure here ray EF or ray EG. You could technically probably call it ray FG if you wanted to as well. Alright, let's talk about opposite rays. If you choose a point on a line and then the point determines two rays called opposite rays. So we have ray BA and ray BC are opposite rays. BA and BC are also called collinear rays. Point B is the common endpoint because it's acting as an endpoint for both rays. An angle is defined as the intersection of two non-collinear rays at a common endpoint. So here in this picture, we can call this angle ABC or CBA. The purple area is the interior. The red area is the exterior of the angle. We have one side of the angle. We have another side of the angle, and the point where the rays meet is called the vertex. Here's a small chart of different types of angles. We have a right angle. Measure of angle A here is 90 degrees. The little box symbol means 90 degrees. We have an acute angle. An acute angle, the measure of the angle is greater than 0 but less than 90, as we can see here. An obtuse angle. An obtuse angle is greater than 90, however less than 180. And then there is called a straight angle. Straight angle, it looks simply like a line. We could say the measure of angle ABC here is 180. It's called a straight angle. There is also called a reflex angle, which is greater than 180 but less than 360. Congruent angles, angles that have the same measure. Notice the little arcs drawn on the figure also indicate that these two angles are congruent. So, given this diagram, angle ANC is congruent to angle YNZ. They happen to share a common vertex. They don't have to be congruent. Congruent angles can be adjacent, connected, share a vertex, or they could be separate. Okay, and then lastly here we have an angle bisector. It's a ray that divides an angle into two congruent angles. If ray PQ is the angle bisector of angle RPS, then point Q lies on the interior of angle RPS, and RPQ is congruent to angle QPS. Okay, and we'll say there's a point Q right here. So RPQ, this angle right here, is congruent to QPS.